Hi guys, it's John here, and today we're going to make this game called Arkanoid. Or at least that's what I thought it was called, but people have told me it's called Brickles. So I don't exactly know what it's called, but it's a cool game where you're this paddle and you destroy these blocks. So let's go ahead and make it. As always, we're going to start very minimally. I just have this material app with right now just a single widget inside it with a black background scaffold. I've added one dependency, and that is Google Fonts, and that is so that I can use the video game font, which I really like. So we're going to refer to this picture. This was from Wikipedia, and I think this is what the original Nintendo version of Arkanoid looked like. We're going to try to roughly approximate this. If I were to make this for real, I'd probably get all these images and use them, but we're just going to do everything using colored containers and things like that. Alright, so let's make these objects. The first thing I want is a base class for everything. This will be relatively straightforward. Everything in the game is going to have a position and a size. And the position will be an offset. And then we'll implement a render method in the base class that will take the animation controller. This controller will basically govern the whole game and keep the frame rate going. And then we're also going to pass in a unit size. What the unit size is the number of pixels per world unit. So everything in the game will be using world units, and whenever we render, we just need to multiply by pixel units. So this will return an animated builder. The animation will be the controller, and then in the builder, we can return a positioned widget. The top is going to be our Y position, multiplied by the unit size's height, and the left is going to be our X position multiplied by the unit size's width. We can also provide a width and height. And for the child, we will provide a method that our subclasses can implement. We'll pass in the unit size here. Let's go ahead and add this method. And the last thing I'll add is a convenience method for getting a rectangle that bounds the object. This will be useful for things like collisions. Let's create our first subclass. It's going to be our paddle. We'll extend from our nifty base class, and we'll add a speed parameter. This is how fast the paddle can move. And in the constructor, we're just going to take a position. We're not going to take a size because we know how big we want our paddle to be, at least at the beginning of the game. It's going to be 3 units wide by 1 unit tall. We need to implement our render game object method. And for now, we'll just return a container with a background color of red. Okay, so let's just create the game with only our paddle. So first things first, we'll create our animation controller, which is going to control the whole game. And in order to have an animation controller, we need to be a ticker provider. So we'll initialize that. Set the duration to some massive number. And then at the end of our init state, we'll just make sure to call forward on this guy. Let's also create our paddle. Initialize that. Now I'm going to set the paddle's position to 926, and this will make a lot more sense once I add my world size. So the world size is going to be 18 by 28. So 9 by 26 basically means that it's in the center horizontally and it's towards the bottom vertically. And I can even subtract half the paddle's width in order to make sure it's in the exact center. Alright, now let's render our game. The first thing I want to do is put everything inside of a safe area. It's just to make sure that the game won't render over or under the info bar and other things that need to appear, like the bezel on an iPhone. So we'll just create a padding. I just want a little bit of padding on the left and right sides. And the child of this padding is going to be a column. The whole game is going to exist inside this column. The first entry in the column is going to be the score. So let's add a score field. So in here we can say text. Underneath that is another text. Underneath this column is going to be the container that holds the actual game. We'll set the background to be blue just so that we can see where our game starts and ends. Make it a dark one. The child of this will be the actual game, which will be wrapped in an aspect ratio. This is just to make sure that our world units are consistently sized. So we can set this aspect ratio to the same aspect ratio as our world size. And then the child of this is going to be my stack, but instead of just directly doing a stack, I want to do a layout builder. And this is so I can tell how big my stack is going to be. So this method takes context and constraints, and the constraints will be the size of the stack. The first thing I can do is calculate the unit size. This is just simply the width of the stack divided by the width of the world. Okay, now I can create a list of widgets, which will be my game objects. And I can add our paddle. Let's make sure to render it here. Use our controller and the unit size. And then I can return my stack. So great, we can see that we got some basic stuff rendering. Our paddle is just a red block and our high score and everything. We can make our paddle look slightly more interesting, slightly more like the original screenshot, just by using some containers with gradients. So I'm just going to do that really quickly. We can add a shadow here. And we'll just make it so that there's a grayish container inside this. And we'll add rounded borders on this external red part. All right, so that looks a little bit more like the screenshot. Let's just make it a little shorter. It looks a little too tall. Okay, that's roughly it. Okay, now let's make the ball. I can copy our paddle, or at least part of our paddle, because certain things are going to be the same. And instead of a speed parameter, I'm going to have a direction and a velocity, or I guess I'll call it speed just to be consistent with the other names. This is a ball, and I'm going to have the position, direction, and speed all be parameters. The size, once again, is going to be hard-coded. It's going to be just half a unit large. And the ball is just a tiny blue circle with a white border. So let's do that. I'm using a really large radius here just to make sure that it's a circle. We'll add the same shadow that we added for our paddle. And we'll add a white border. Now let's add some balls to the game. All right, so we have our paddle and a little ball here. A couple things I just want to call out. The first is just that the initial direction of the ball, I'm using this nifty offset from direction method. This is a cool method where you just pass in a radians and you get a unit vector based on those radians. And the other tiny thing I just want to call out is since balls is a list, I'm using this add all and I'm just mapping my balls into a rendered widget. Alright, now this game is pretty boring unless these things move around, so let's do that. I'm going to create an update method. This will update the entire game. Now in order for this to work properly, I need a few things. I need the current time in milliseconds. I can get that directly from date time now, milliseconds since epoch. I need the delta time because I'm going to be calculating a bunch of positions based on current positions, velocity, and time elapsed. So I'm going to create a delta milliseconds. That's going to be the current time minus the previous time. Previous time is something that we need to set up and make sure we manage properly. So prev time milliseconds, we'll initialize it to 0, but we also need to set it to the current time right before our animation starts. All right, and then we also want a delta seconds. That's just going to be delta milliseconds over 1,000. And then at the very end of this function, after we've done all of our work, we'll set the previous time to the current time. First things first, let's update our paddle. I want to put 2 additional members on the paddle, a left and a right, and if paddle is left and the paddle's position is greater than 0, meaning we're not against the left wall, then I will move the paddle to the left. So in order to move the paddle, we're just adding its position. We're adding the speed times the amount of time that has elapsed. Just kind of a simple velocity equation. If paddle.right and the paddle position plus the paddle's size is less than the world size width, then I can move to the right. So similar thing here, except we're just doing a plus instead of a minus. Now I need to add these 2 parameters, left and right. Start them out as false. And let's add 2 buttons that set these values. We'll put them in our column at the very end. I'm going to make my own class for these. So it'll just be a row of, I'll call it BTN for short. There's going to be 2 buttons. The child of each of these buttons is just going to be the icon. This is going to be a stateless widget. And it's going to take 3 parameters. There's going to be a function for when the button is down, or when it first goes down, and then a function for anything that causes the button to come up. And this is important because a cancel event will also cause the button to come up. It's kind of different from a normal button where with a normal button, if you cancel, it doesn't count. With this button, it's either down or it's not down. We'll also have the child. And I'm just going to return a gesture detector. The child will be kind of an orange roundtangle. And the child of this container will be a centered, and then the child of the center will just be the child that's passed into the button itself. Now inside of our gesture detector, on tap down, we'll call our down function. On tap cancel, we'll call our up function, and on tap up, we will also call our up function. Okay, cool. So let's expand both of these. And then we can just make these a little taller. All right, that looks pretty good. So now when you press these buttons, so down, I just simply want to set my paddle left equal to true, and then up, paddle left is going to equal false. Same thing with this button, except it's going to be paddle right. Okay, now in order to properly get this to work, I just need to do one more thing. Nothing is currently calling this update method. So in my init state, I'm just going to add a listener to our animation and call update. So this should call update for every frame. Let's restart. Okay, and then lastly, this isn't working because my paddle speed was never initialized. So let's go back to our paddle and we'll just set this to 10. This is a value that I've played with and it feels pretty good. Alright, so now you can see I can move my paddle around. Let's get that ball moving as well. We'll multiply the direction by the velocity, and then multiply all of that by the delta seconds. Keep on saying velocity, I mean speed. So this should make our ball fly off of the world. Now we want it to ricochet off of things. So the easiest is to just get the wall ricochets working. So if it hits the right side, which is this if case right here, then we just want to reflect the x direction. So we can simply set the direction equal to the negative x direction, and we'll just keep the y direction. And once again, if the ball ricochets off the left side, then we will negate the x direction. If the ball ricochets off at the top of the screen, then we negate the y direction. Alright, let's see if these work. Okay, we're not seeing the ball ricochet off anything. Let's make our ball start headed in a different direction. Instead of 0.9, let's set it to negative 0.9, which will go counterclockwise instead of clockwise. Okay, so we have our ricocheting ball. It's going right over our paddle. So let's make it ricochet off of our paddle. So this is when we're going to process collisions. So we need to grab the rectangles, we'll grab the ball rect, and we need the paddle rect as well. If these two rectangles are overlapping, we want to find the intersection of the two rectangles. That will help us figure out which direction the ball is coming from. If you think about the intersection of two rectangles, here's two rectangles. So if the intersection's width is greater than the height, then that means that we have a vertical intersection, or the ball was coming in from the top or coming in from the bottom. And again, if the intersection's height is greater than the width, then it was coming in from the left or from the right. So we'll use that information to guide us here. So this means the ball is hitting the face of the paddle. And the way we ricochet here is the most interesting. We don't want to do a perfect mirror symmetrical collision like we do in other cases, because then you would basically have no control. So we want to make it so that when it comes into the paddle we want to make it so that when it hits the edge of the paddle, it ricochets off at an extreme angle. But if it hits the middle of the paddle, it ricochets off straight up. And that will give the player more control over where the ball goes. The first thing we need to do is just make it so that the ball is no longer inside the paddle. So we'll set the ball's position. We'll subtract the height of the intersection, because we know that this is a vertical intersection. So if we subtract the height, then that will push the ball outside of the paddle. We want to figure out how far along the paddle the ball is. I'm going to call this paddle percent. This is basically just going to be the ball's position plus half of the ball's width minus the paddle's position all over the paddle's width. So this is how far along the paddle the ball has struck. 0 on the left, 1 on the right. Now we can just multiply some angle range by this 0 to 1 value in order to get our bounce direction. I want the angle range to be almost 90 degrees, but not quite. So what I'm going to do is say max angle pi times 0.8. So pi would be 90 degrees, but I don't want it to go quite to 90 degrees, so we'll do that. So the actual direction, once the ball bounces off, is we can use our from direction. I'm going to do negative max angle, which is a counterclockwise rotation almost to 90 degrees, plus the max angle times this percentage. So as the ball gets further along the paddle, it'll go from negative 90 to 0, which is, positive in this direction. Okay, so let's try this out. Okay, looks pretty good. One other thing I should make sure I'm doing is similar to here where we push the ball outside of the paddle. I want to push the ball outside of the walls when it touches the walls. So on top of setting the direction in all three of these cases, I'm also going to just push the ball a little bit. So let's do the three other cases for the paddle. There's a left collision, a right collision, and a bottom collision. So we can add some else ifs here. And we're going to bounce the ball to the left. So we can just say negative ball.direction.dx, but absolute it. So this will always be a negative number. And then we also want the ball to shoot in the downwards direction, because if it strikes the left or right side of your paddle, it's gonna go down. Okay, so similar is the right collision. And then the downward collision, which I don't think ever happens, but never say never. We're just going to set the position to the bottom of the paddle. And we're going to set the direction to be a straight down vector. Cool, so this should be all of our ball handling. Let's add some bricks. Going to once again, I'm just going to copy our ball class and create a brick class. The brick is just going to have the position and size from the base class, but it's also going to have a color. The size is going to be 2 by 1. And for the rendering, I'm just going to render a color. We'll use green. Now we can add some bricks. And I just realized I should be using the color that you pass into the brick instead of just saying green. So let's go back to our brick and just set this to the actual color of the brick. Now we can, similar to how we render the balls, we can also render our bricks. All right, let's add a couple more bricks. Okay, now let's make it so that you can hit the bricks and destroy them. So inside of this loop where we're iterating over all of our balls, we can also, on top of checking our paddle, we can check our bricks. Once again, we need to get a rect for our brick. So we'll add to the score if you destroy bricks, and we'll get the intersection. We can check the intersection's height, see if it's greater than the width. And if this is the case, then we know that this is a horizontal collision. So let's push our ball. Since we don't know which direction our ball is headed, we can actually use the ball.direction.dx sign. This will be a positive number if we're headed right, and it will be a negative number if we're headed left. which will properly multiply this width and move the ball in the correct direction. So we're just going to preserve the ball's Y position. And then for the direction, we're just going to simply mirror it over the X. And in the else, that means that this is a vertical collision. We'll do something very, very similar, except we mirror in the Y direction instead of the X direction. Okay, so let's see if this works. All right, cool. So we're colliding with our bricks, but I want to actually destroy the bricks when we collide with them. So let's add that logic. Add a list of bricks. Call it destroyed bricks. And if we collide with a brick, it's destroyed. So we can add it to this collection. And then at the end of this function, if that collection is not empty, then we can call set state, because we're actually going to modify the state of this widget. And we just say, okay, so this will remove our destroyed bricks. These bricks look pretty terrible to me. I want to follow this format that these bricks have, where they have this kind of light, it almost makes the brick look 3D. They have this light and this dark here. These bricks are flat. I want my bricks to look like this. So let's emulate that behavior. So in order to do that, inside my brick class, instead of just saying, return container, I'm going to return a custom paint. And my painter will be a brick painter. And I'll just pass this color in because I'll probably need it. All right, bricks should not need to be repainted, so I'm going to return false from should repaint. And I want to take the color, so this will be the color of the brick. And I want 3 paints. I mentioned I want the main color, and then a lighter color and a darker color. Let's get the other 2 guys. All right, and for these light and dark ones, I'm just going to linearly interpolate the color. So for light, I'm going to use white, because white is lighter than any color. I'll try 0.1 at first. For dark, I'll use black. And then for the painting, at first, just to get something on the screen, let's just say draw rect. Okay, so we're drawing our bricks. We can switch to the light color just to make sure that that's kind of working. It's only slightly different, but it'll be more obvious once we add our facets. So in order to do our facets, we're just going to draw 4 little mini paths. This first path, if we look here, is going to be the upper left corner of some inner rectangle, the upper left of the outer, upper right of the outer, and then the upper right of the inner. So first I need to get that inner rectangle. I can deflate the outer rectangle by, let's just say, 8. So as I mentioned, I have the upper left of the inner. Move to the upper left of the outer, which is rect. Move to the upper right of the outer. Okay, so it's kind of hard to see right now, but you can see just a little facet. Now I deflated that way too much. Let's do 4 instead. Okay, very, very subtle effect. Let's add the rest of our facets. Okay, I think these bricks look a little bit better now. They kind of have that 3D effect. Let's put a black line around them. Okay, that looks okay. Let's add a couple more blocks just to kind of see how this looks. We have a bug here where the ball just kind of goes right through the bricks and melts them like they're nothing. It's kind of cool, but I definitely want to fix that. I think the key here is that the ball should only be able to ricochet off of one brick at a time. If we do find a ricochet, we can just simply break after this. So we'll just stop looking at the rest of our bricks to make sure that we don't just melt through our bricks. Okay, cool. So this is starting to look pretty good. The next thing I want to do is the background to this game. I want it to look kind of similar to this. Now you could just do this as an image, and that's probably the right way to do it. But I want to show you guys how to do a custom box decoration. I'm not going to put it in this main video, so I'll just show a little link in the corner. But if you're interested to see how to build a custom box decoration, you should check it out. It's really interesting. But for this video, I'll probably just skip right past this section, and we'll meet back up here once the box decoration is finished. All right, so we've done our background decoration. You can see this is a custom drawn thing, so you can really play around with it and do some different colors, things like that. Let's just see what this looks like. Yeah, it looks kind of cool. Anyway, if you do want to see how that's done, you can just click that link in the corner, or I will put a link in the description. Now let's add shadows to these bricks. But I can't do the shadows like I did for the ball or the paddle because I don't want them to draw on top of each other. So what I'm going to do is just have a separate method for the bricks. Alright, so let's just copy the box shadow from somewhere else. Now before we draw our bricks, we just want to draw all the shadows. Oh, and obviously we need to position this. Okay, that looks a little bit better. So now let's add the power-ups. Every time you destroy a brick, it has a certain probability of dropping a power-up. So let's go ahead and do that. Now I'm going to do this really quick. You've already seen me create a bunch of these game objects. So I'm only going to cover the very important details, but let's do this. So I'm adding a power-up type enum. This will just be the type of power-up. For our purposes, we'll just have these 3 different types. This will increase the speed of your paddle, this adds a ball, and this will increase the length of your paddle. I want type to have these useful methods on it, so we can add an extension. Each power-up is going to have a single letter that is... Sorry, that's my dog screaming. Each power-up is going to have a single letter that represents it. Alright, and then the child of this container will just be the letter itself. Let's render some of them just to see what they look like. So in our update function, we're just going to move them down the screen by some amount. So it'll move down at a rate of 4 units per second. Let's go ahead and render these. Okay, so that's what our power-up looks like. Now, if you collide with it, I want to consume it and add some effect to the game. So let's do that logic. So if the paddle rect overlaps this power-up rect, then this power-up is consumed. We're going to destroy it in a similar way that we did our bricks. We'll increase our score by 500. And here's where we figure out what the power-up is going to do. If it's a length power-up, we need to increase the size of the paddle. In order to do that, I'm going to add a new property to the paddle called desired length. And we'll just say plus equals 1.0. It's going to increase it by 1 unit. If it's a speed power-up, this one's a lot simpler. We just increase the paddle speed. And if it's a balls power-up, we add another ball into play. We'll add the ball directly above the paddle. Now we need to do a couple things. We need to add this desired length, and we need to make sure our power-ups are consumed. Let's do the second thing really quickly. Okay, and now let's add our desired length to our paddle. Now in our update function, we just want to make sure if the desired length is greater than the paddle length, that we're expanding the paddle a little bit. So the amount of growth is just going to be equal to, let's say we'll grow at 0.5 units per second, and we need to multiply that by our time that has elapsed. So what we want to do is set our size to a new value, where it's paddle size width plus the growth amount. And the height never changes, so we'll just copy the height over. And the paddle's position has to also move. This is so that it looks like the paddle is kind of expanding from the center. Okay, so let's see how this works. Okay, so that's pretty good. And that's about it. I mean, there's a lot more we could do here. In the repository that I'll share in this video, I just have like a very simple game over where if both of your balls go off the screen, it game overs. I won't do that right here just because it's super simple and I've kind of showed you the hard bits. There's also blocks that can be hit more than once in the actual game, so we could implement something like that. But that's pretty straightforward, so I'll leave that up to you if you're interested. But yeah, that'll do it. Thank you so much for watching. If you enjoyed this, please like and subscribe. And let me know in the comments if you have any ideas for other games we could implement or just other videos we can do in general. I really like doing these, and I really like to hear from you guys. See you next time.